Hello everyone. In this video, we're going to work with the hydraulics library and specifically focus on using a directional control valve or a DCV. The first thing I'm going to do for my hydraulic system is bring in a fluid properties component, and I'm also going to bring in a tank component because I know I'm going to need this later on. Then going to the directional control valves, under four-way valves, I'm going to bring in a DCV 4-3 close. Now when the input is a -1, I'm in this first configuration. When the input is 0, I have nothing connected, and when the input is +1, I have this configuration. Now I'm going to add the other pieces. I am going to connect this to a double acting cylinder. So the goal here is to use the DCV to move the cylinder forward and backward. Now I have these 1D translational ports on my cylinder, so I do need to bring in a fixed end. So I will fix the left side, or the port A, and then I'm going to also add a mass on the other end where the piston is, and I'm going to set this mass to be a metric ton, so 1,000 kilograms. So this is representing the mass that I want to move in my system. I made it heavy just because we were working with hydraulics, very common to have heavy objects that you're trying to move. And really all I need now is a source. So I'm going to bring in a fixed pressure source, and I will reverse the direction so that's moving from A to B. And I'll set the pressure difference to be 20 megapascals. So I will connect here and then connect to my port P, and then T is just going to go directly to tank. I will add a probe at the end of my mass to measure the displacement. So I'll just call this displacement. Another thing to take note of is when you're working with the hydraulics library, the recommendation is to change your solver settings so that you're using the Rosenbrock or our stiff solver. So now the only thing I'm really missing is my input signal to the DCV. So just for testing purposes and to make sure I'm understanding the component correctly, I'm going to bring in just a constant signal. So I will start with the default 1. So again, that should put me in this configuration where P is connected to A and T is connected to B. So fluid or hydraulic fluid is moving this direction and will push my piston out. And so of course we see the mass moving in an increasing, having an increase in the value because it's moving from left to right. That's defined as an increase. Now it's showing here that I'm going up to 12 meters away, so I'm going to stop that by going to my component and setting end cushions. So this is going to limit the motion, and I'm going to set an upper bound of 0.5 meter and a lower bound of -0.5. So of course this is being measured from the center position of the position. That's just how I've defined it in this case. I can then test the other direction, -1. So of course now flow is going from P to B, so my displacement is going to be negative because I'm going in the opposite direction, and I should hit my end cushion. So in this case we see it decreases, but once I hit that -0.5, my piston no longer moves. I've hit that end cushion. So now of course we want to create a more realistic signal, something that goes from from 0 to 1 and then down to -1. So to achieve this, I'm going to take polyramp, which is just a very smooth version of a ramp. So this first one will go from 0 to 1. I'll make it go over 3 seconds. And I'm going to add 2 of these ramp signals to get exactly what I want. The second one, because I'll already be at +1, I want to decrease by 2 to get myself down to -1. I'll start this at 5 seconds in the simulation time, and I'll make the ramp 3 seconds as well. I'll add an add component so that I can add these 2 signals together. And this is what I'm going to connect to my DCV input. Finally, I'll put one last probe just so I can measure the input into the DCV. Make sure it's the signal I'm expecting, and I can run another simulation. So now I'm expecting my mass to move forward, hit the end cushion, or the piston hits the end cushion, so the motion stops, and then hold the position. And then as my DCV signal heads towards -1, we see that the piston is moving back until the piston hits the other end cushion, and again, my displacement stops. So in this video, we were able to look a little bit into the hydraulics library and really investigate how the DCVs work in MapleSim.